in the background here. If anybody needs to go in or out, that's where I'll be. So I'm going to mute everybody's microphone. So for those who are speaking, you can unmute yourself. And I ask that you also shut off your video just to save bandwidth. So the little stop video in the lower left. So do that, and I'll mute the microphones. All right. So Harold, you're muted. We can't hear you. All right. I think I just unmuted you.
You did.
All right.
All right. So when I call on you for our committee reports, you're going to have to unmute yourselves. And if you want to show your faces again, you're welcome to do that. Welcome, everybody. This is something we talked about a couple weeks ago when we had to cancel the March meeting. I'm still getting questions about whether the auction is happening online or not. We're going to push that back till the fall, as you saw in the newsletter. We're going to try and do this as normally as we can. We'll start with our typical committee reports. I don't have a lot to present. I'm not going to do a slideshow. And then that'll leave more time for our presenters because we have 3 presenters tonight. And I know all 3 of them have some interesting stuff to share with us. So let's go right to Brian. Talk about new members and what's going on there.
Just one new member, I believe, probably around maybe 2 weeks ago or so. His name is Edward Sweezer, if I'm pronouncing that right. And unfortunate that all this happened right when he joined, but hopefully he's with us tonight. And if not, at least hopefully he's on YouTube. So welcome.
Thank you. Lewis, Treasurer's Report?
Yeah, so there isn't much to report other than the fact that we're now at 136 members, which was a pretty good rebound considering that, you know, an early part of the year, we got down as low as 104. So thank you so much for signing up. And of course, anyone on here who hasn't, it's super simple. Go to the website, log in. There's going to be a $sign, tells you how to re-up. We really appreciate supporting the club. And thank you very much.
Thanks, Lewis. Despite the fact that Lewis and I went to a Citizens Bank in January to ease the transition of treasurers, which is such an ordeal every 3 years, until yesterday, Citizens still had Lewis locked out of the account. So if you gave him checks, he couldn't do anything with them. He's starting to process them now. If you know you paid your dues and you haven't been updated on the website,
yeah,
email Lewis, yeah, and he can fix that and make sure you're current.
And I only know of one check that I have that has not been processed because I went to the bank twice to do things. It was just getting the online stuff. But again, you know, please reach out and we'll try to get you settled. Thank you.
Thanks for your patience, everyone. I don't see Nate here. We're not really sure whether Cherry Springs will be open by July. So we're going to take a wait and see attitude with respect to what happens for the next star party. Janet, you said you didn't have a report, but if you've changed your mind, anything you want to add? Jeremy, unmute your mic.
We aren't scheduling any new outreach events, so we have to wait and see what happens there. But we did have some at the beginning of the year. So I think we had about 60 people that we reached, but have to stay tuned for the rest of the year, I guess, to see what happens.
Yeah, it's a shame. That first event was extremely successful. We got a few new members out of it, and then we ran smack into the pandemic. Hopefully we'll be able to pick up where we left off and keep that momentum going. So thank you. Observing report. I remembered it this time. Andrew, you're on.
Thanks, Harold. I'm not going to share my video. Just let me share my screen here. Can you all see that?
Excellent.
Or somebody with an unmuted mic say that they see that?
Yes.
Yes.
All right, great.
Got it.
So before we dive into the observing report, I just want to say all star parties are canceled until further notice, of course. We canceled the April one about a month ago, probably, or so. It was very soon or very early. And Valley Forge as a whole is canceled. The park is closed. So we will be coordinating with them and following CDC guidelines as to when we can resume them, and when we will resume them, we'll let everyone know. So, all right, but here's the DVAA observing report for April. And I wanted to continue my theme of doing backyard observing. However, I thought that I was thinking about what to talk about, and I thought, oh, maybe I can come up with something a little more unique to our unique situation here. I don't know. Of course, you can go observing by yourself. It's much more fun to do as a group. But if you have a nice backyard, you can go observing. I, for one, do not have a good backyard. I live in downtown Phoenixville, lights everywhere, neighbors are really close. But I just thought this is a really unique opportunity. If you're like me, if you're at home or if you're going to work still, you're still going to have a lot of free time. All of my clubs and activities have pretty much been canceled, so I'm at home a lot. And I thought, well, what a unique time to really sit back while everything's on hold and to really think about, what you like to do, and more than anything, really, like, think about what you're trying to get out of things that you like to do. So I was going to talk today about what are your goals for being an amateur astronomer. So I broke this up into kind of experience categories: beginner, intermediate, and advanced. And I'm just going to list a few goals that I came up with. They include observing, gaining more knowledge, or maybe even new equipment. And then I put a list of Astronomical League awards for each level, because what better goal resource than to look at the Astronomical League programs? They're all great, and they all fit these 3 experience levels very well. I'll give some list of resources, maybe not specific resources, but then in general, like where to find these things. And I just, throughout the presentation, I want you to keep in mind, these goals can span any timeline. You don't need to finish it in a month, a year, 3 years. It can be whatever you feel comfortable with. This isn't a complete list. It's just what I thought of in my 2 or 3 nights of preparing this presentation. And of course, it's not confined to experience levels. You might see something in the intermediate that you think is more advanced or more beginner, or in the advanced and so forth. So really, I just want to get across, like, this is a unique time that's given us, and maybe it's a nice time to reflect on what you like to do. So what are some beginner goals that I thought of? Of course, buying your first binocular or telescope purchase. That was a great time. There's not a lot of distractions. Go do your research. Think about portability. Think about what you want to see with it. Think about where you're going to be doing most of your observing. Really just find the one that is right for you. There are many articles online. I know a lot of the telescope manufacturers like Celestron and Orion have great articles. And then, of course, there's the magazines like Sky and Telescope that have good articles too. And then ask the club group for help. Put an email out there on the links, or in the Yahoo group, or now it's the IO group. And ask for help if you have any questions. We're all still here, just not together. Learn the constellations. Now it's a great time to just kick back, relax, and read some books, find some charts or some websites, and kind of memorize these constellations as you can. Learn how to use a star wheel. That's a really good beginner tool. And you don't even need a telescope for this. And you can do this in any backyard, really, because it can be done in urban skies. Just go outside on a clear night and in your backyard and see what you see. See how many you can memorize, or maybe even like go down to the southern hemisphere, sections of those charts that you don't know of, and try and memorize some of those. And lastly, make a dark sky trip. Of course, when we're able to go and travel again, we will get there eventually, I promise. But maybe this can be a goal for something to do right out of the gate, right when we're able to do things again. So make a first trip to a dark sky location, wait for a new moon to get there, make a list of objects that you've never seen before, and learn some tips that will help you. That will help you advance your observing skills from just what you're doing in your backyard. So Astronomical League Awards, what are good beginner Astronomical League Awards? So there's the Astroms observing. Astroms are a little different than constellations. If you don't know, they're just they're other shapes in the sky, but they're not usually considered an actual constellation. There's the Carbon Star observing. The Constellation Hunter, both northern and stellar, great thing to do while you're cooped up inside preparing for that one. The Galileo observing program, very unique. Going through doing the same type of observations that Galileo did. Of course, there's lunar observing, meteor observing. Sky Puppy is something you can do with your kids. I know they're cooped up too, pretty much. It's designed for children 10 years or younger. And to be honest, it's even great. You can't get the award because there is an age limit, but it's even great for any kind of beginner astronomer. You don't even need a telescope to complete that one. The Stellar Evolution, very interesting a program, that one. And then also the Universe Sampler, giving you easy targets kind of all the different objects. So intermediate goals, change up your equipment. You know, maybe you bought a telescope, you bought some eyepieces, you've been using that for a while, you're pretty familiar with them. Maybe it's time to branch out. Maybe get a different eyepiece, finder scope, mount, telescope, you name it. Use different filters. Maybe you haven't used any filters yet. So put it on a nebula or something and then try switching filters out. See how that changes things. And then try some other charts and books. I know that when I was doing the Messier list, I was able to use that Pocket Sky Atlas. That got me through all of it. But then when I was trying to do some of the other ones, I had to buy other charts and books that went down to lower magnitudes. So this might be a good time to get one of those and start studying it and get familiarized with it. Observing events. So I know when you're first starting out, you might be so interested in all the basis and stuff, you might be missing some events that are happening. Well, maybe make it a goal to attend or to observe some of the events. There's a comet happening right now, Comet Atlas. You can read my article about that in the newsletter this month. It's going to be pretty spectacular. It's already very bright. Check out some occultations and conjunctions. There's a really nice Pleiades and Venus junction going on yesterday, but you can still go out and see that over the weekend. And then maybe some moon transits, some transits going across Jupiter with the moons and such. And also do some traveling. Once we're available to do that again, if you can't see anything in your backyard, then go travel to see some of these things. Learn more about a specific topic. So maybe you have a favorite object, or maybe you want to know more about the history of certain telescopes, certain observatories. Now's a great chance to read up on anything that you've wanted to know more, that you're just curious about. And find another way to enjoy the hobby. You know, you're a beginner, you just started out, and now you've kind of advanced, more intermediate, you're more comfortable with things. Maybe try outreach events, other events that you haven't gone to yet. Maybe you try astrophotography, drawing, recording. There's lots of ways to enjoy amateur astronomy rather than just looking through your telescope. And of course, invite your friends. So it's always more fun together as a group. Some Intermediate Astronomical League Awards, the Messier Award, the classic. I kind of see that as a step from beginner to intermediate. There's the Caldwell list, which does include a few southern objects. So that's a pretty interesting one. Common Observing, Deep Sky Binocular list, double stars. Now you're getting into the actual classifications of objects, the double stars, globular clusters, open clusters, planetary nebulas. There's even another Lunar 2 award that they put in the the intermediate category. So go back and revisit the moon. And then we have observing, or urban observing, which can be good for the beginner and can be a little challenging when you want to see some fainter stuff out there. All right, and moving on to advanced goals, go old school. So you might have already done this in the intermediate phase, or maybe you want to go even farther, but try not to use any go-tos or computers when you're out there. Really go star hopping. Use those really what I call dense charts with lots of stars on them to find those really faint, challenging objects. More traveling. Go darker, go farther away, maybe go to the southern hemisphere. I've never been in the southern hemisphere. That would be really interesting for me. And travel to celestial events like different eclipses and things where you might need to go quite a distance to get to. Of course, upgrading equipment. Maybe go for that favorite eyepiece that you've always wanted, or that filter upgrade that you've really wanted. If you're into astrophotography, get that camera. Aperture fever. We've all had it. And then learn more what I would call extreme techniques. These are things that you might not do for every single observing session, but if you're going for like the Arcticula galaxy or something, you really want to conserve your night vision, some of these things might need to be taken into account. So like using your eye patch, maybe wearing some darker glasses throughout the day, things that you can do to prepare yourself throughout the day. And then really test your limit of your eye and learn how your eye responds to the objects and how dim can you actually see with your eyes today. And here are the Advanced Astronomical League Awards. Of course, the Arpacule Galaxy, the Bright Nebula, which are emission and reflection nebulas, the Dark Nebulas, which is a really great program. You know, dark nebulas are interesting to see in photographs, but your eye can't see as many stars in photographs. So the dark nebula a little harder to pick out with your eye. There's the Flat Galaxy, where we're looking at edge-on galaxies and galaxies that we're looking directly flat onto. There's the galaxy groups and clusters, Herschel 400, and if that's enough, there's always the Herschel 2 as well. And I want to add, these aren't all of the Astronomical League Awards. These are just a subsets that I chose for each of these experience levels. And again, there's many, many more. This is just what I came up with. Use this time to reflect and really gain new interests in something that you've always been interested in. I think it's really unique. The world stopped, and I don't know if we'll ever have this opportunity again. Use it to your advantage. So, all right, that's all I got. Thanks, everyone.
Thanks, Andrew. That was great. I scribbled down a bunch of those programs because we have quite a few people who get through those, and be good to see more doing that if we ever get a clear sky sometime, a non-windy clear sky. So we have 3 speakers, and one of whom is a special guest who I just learned is going to join us with some new information, and that's John Conard, who was with us earlier a couple months ago. So John, the floor is yours.
It's Steve, by the way.
Steve, it is Steve. I'm thinking John Conrad. That's my bad.
All right, let's see if we can share here. There we go. So I'm going to talk real briefly about the New Horizons Parallax program. And basically what we're doing is we're out at 47 AU now, and we're going to be taking images of 2 close stars to Earth. One is Wolf 359, which is available to us Northern Hemisphere observers. The other is Proxima Centauri that, unless you're going to go down south, you're not going to be able to see. And we're going to take these pictures at a time when you can take a picture from Earth at the same time and use the New Horizons picture in conjunction with yours to create a 3D picture of Wolf 359 on its background star field. This was going to be on April 23rd. It's at the best opportunity for people on the East Coast is at 4 UT, which is midnight right now. Wolf 359 is in Leo. It's on the star chart on the right there. And by the way, I did give these charts to Jeremy, and he's welcome to circulate them or post them, whatever you guys normally do with charts on your website. It is a 13.5 magnitude star, but it is very red. So it actually acts a little bit better than that with a good camera. The Wolf Star Catalog is a catalog that was put together 100 years ago of high proper motion stars, which is why Wolf 359 is one of them, because it's less than 8 AU away. I'm sorry, light years. It's also a star that has some interesting background to it. I'm not going to spend a lot of time to this on this, but there are 3 sci-fi things that at least I could come up with quickly on Wolf 359. One is from Star Trek Next Generation, which is, I guess, one of the Borg Wars. Another is an Outer Limits episode from season 2, which is actually an interesting one. I like that one. And last, there's a radio podcast called Wolf 359 that's just hilarious about a dysfunctional crew on a aging spacecraft orbiting Wolf 359. Here's an image that Jackie Donaldson, one of my buddies, and I took back in February before all the COVID stuff really took off. We went in my backyard and we used my C14 with the Hyperstar. So we're running at f1.9. And we used Jackie's ZWO camera, and this is a 6-second exposure, and that arrow there is pointing to Wolf 359. And of course, I've rotated it for north up, flipped it because you, with the hyperstar, you get the backward star images. And I cropped it down so it was rectangular again. And then here you are comparing it to the Finder chart that's on the New Horizons website. If I just crop it down to about 15 minutes square and have really nice correlation. And you can see how bright Wolf 359 ended up in the 6-second exposure when you compare to the stars that are right around it. So anyway, this is a really unique opportunity that I don't know when there'll be another opportunity like this. Maybe we'll do it again on New Horizons in a few years when we're further out. But you know, I really encourage you, if you have a 4 to 6 inch telescope with a camera or larger, you can record this and make your own 3D image from it. That's all I have.
Thank you. Interesting challenge, and we have enough photographers in the club that I expect that a few of us can, not me, I assure you, but but a few of us can take on this challenge. We have now, speaking of photography, we have 2 programs on astrophotography, and speaking first is going to be Irv.
Okay, thank you. Let me share my screen. Okay, can everybody see that now?
Yes.
Okay, good, thank you. So welcome, my name is Irv Schlanger, and what I'm going to present today is how to do wide field astrophotography, quick and simple, one shot. So this is a great way for those of you that are thinking about getting into this. You don't want to jump into the deep end of the pool first. You probably already own the equipment. Camera, tripod, that's about it. So a couple things. Lou and I worked together. We went through each other's presentations a couple times over the past week to make sure that we didn't overlap. I'm going to take the wide field. Lou is going to take the deeper objects, which tends to get more technical. Again, this is a good starting point. So right here, what you're looking at, this is Cherry Springs State Park. This is a panorama. Was shot this past summer, July 4th weekend, roughly. And it is 4 photographs stitched side by side. Each of those is a single shot. Another thing that Lou and I talked about is that this is the overview. Each of these topics that we're going to present could be a lecture in and of itself. We're both willing to do some workshops because that'll probably be, you know, if there's interest, we can get into the software, the post-processing. For now, we're just going to overview. The importance of dark sky, I'll show you that coming up in a next slide. Equipment, we're going to talk about that. Camera, tripod are most important. Technique, exposure. Polar alignment, I did not use that for the shots that you were just looking at, but you can. I went out last night and I did something, or 2 nights ago, whenever it was clear. And I'll show you the difference with a simple Barndoor tracker that I'll show you, the one that I made myself. And composition, important to have that. So here we're looking at Blue Mountain. And thank you, Frank, for everything that you do for us. Versus Cherry Springs. Both are really good. The darker the sky, as far as single shot, you know, non-stacking, you can get a lot more detail. There's a lot you can do with stacking. That's for a future lecture. Again, stuff you may already own. DSLR, you're going to need a wide angle lens. The faster, meaning the wider that that lens opens up, it's kind of like diaphragm in your eye. The wider it opens up, the more light you let through. The fastest lenses generally that you can buy without taking out a mortgage on your house is f1.2. 1.4. You may need to stop down or want to stop down a stop or so from that to avoid vignetting. Generally, lenses perform the best in the middle, like around f8. There's some clubs that are called f8, another one f11. That's getting to a point where you're not letting a lot of light through as far as astrophotography. Remember, it's dark. We need to open up wide. And a tripod. Heavier the better, but you can get away with something light. DSLR. For wide frame, wide field, you would probably want to use a full frame camera. If you're using a crop sensor, a smaller sensor, you have a multiplication factor called a crop factor of 1.6. Then it would be better if you're using a telephoto and going deep, because it'll magnify. Your 400 millimeter will actually become like a 450-500 equivalent. But on a full frame, that 16 millimeter lens will stay at 16. With the crop factor, it's going to go to like a 20-24, and it might not be wide enough. There are dedicated cameras, DSLRs, for astrophotography. Canon came out with a new one fairly recently. Their entire R line is a new line of EOS cameras, and they came out with the RA, which replaces the DA. You can see the difference. The RA astrophotography shot is on the top. The standard new R camera is on the bottom. Should you run out and buy it right now? No, absolutely not. You know, use what you have. If you become totally addicted, yeah, then you might want to consider it. According to Canon's website, the camera's internal filter in front of the sensor is modified for enhanced night sky recording. It's got approximately 4 times the transmission in the hydrogen alpha 656 nanometer wavelength. And according to their website, it is not for quote unquote normal everyday photography use. So this is going to be dedicated. It's $2,500. So again, once you become addicted, and you will, then you can consider it. For now, use what you have. Get used to it. See if you really like it. Lenses, I already said faster the better. The first lens, I'm a Canon fan, if you haven't figured that out already. That's the lens that I used for the photographs that you're going to see in here. The 16-35 zoom, f4. It's a little bit slow, which means you're going to have to increase your exposure time or up your ISO. But it worked. They do have a newer version, which is an f2.8, so it allows more light through, double the price. There is a fixed length 14 millimeter f2.8. Fixed length lenses tend to be sharper compared to their zoom counterparts. Again, more than twice the price. Sigma has some decent lenses that will save you money. The one that is highly recommended by people doing astrophotography, this one will not save you money, is the one with the check mark on it, the 14 millimeter f1.8. Again, it's fast, $1,600, great lens. And then they have other ones that are probably going to be like a third the price of a comparable Nikon or Canon lens. And they do make mounts for all the different manufacturers. So you can take your pick there and save a good bit of money. And if you're really on a budget, even cheaper, Rokinon, I believe that these are all made in China. I think it's a Chinese brand. They've got stuff in the 10 millimeter, which is getting down near fisheye, f2.8, 12 millimeter 2.0. And again, they will make these for both Canon and Nikon mounts. The price range on these is about $200 to $450. Tripod should be rated to hold at least 20 pounds. more if you're planning on eventually getting into auto tracking. Carbon fiber has advantages. It's lighter weight. It absorbs vibration better. But again, costs about twice as much. There's a little tripod on the left. It's a Joby. I have that exact model. It's about.
What did we buy? Oh, Waymo. Okay. I don't know what to. Oh, Untitled.
Is that one of the new ones? Yeah, you want to try one of the other ones?
Yeah, whatever. You know what I need to do?
Somebody's not muted.
I don't care if it tastes like dirt. I like the label. I'll buy it.
Okay. Can everybody still hear me?
Yes.
Okay, good. So the Joby, it's rubber balls that they're bendable. When I was up at Niagara Falls, I wrapped that around the railing right up against the falls, and I did keep the strap around my neck just in case, but it held on really good. For nighttime photography, they were banning, because it was 4th of July weekend, they were banning full tripods. So I wrapped it around the street sign, and I took great photographs of the fireworks over Niagara Falls when most people couldn't get it. The second one is an aluminum tripod that, you know, you'll get those at a decent price range. Keep in mind, metal gets cold at night. And on the right is a carbon fiber, worth the investment. Light pollution filters, you hear about those quite a bit. They generally tend to be very thick, and if you're going to go with wide angle lenses, you're going to start to vignette. And if you look at the corners of the photograph I have here, you'll see that it's darkened in all 4 corners, and so I chose that one deliberately for this, and that's vignetting. Again, you can stop down and get rid of most, if not all of it, but once you start stopping down, the higher f-stop numbers, each click, you cut your light in half, which means you double your exposure time, which means you get star trails, movement, or you have to up your ISO.
Irv,
Yes.
explain what vignetting is.
Sure. So if you look over here, I don't know if you can see my mouse, but if you look at the 4 corners, you'll see that they're dark, much darker, say, than the center of the photograph. That's vignetting. It's when you start to get the edges of the filter in the picture. Some people like it. There are applied filters and processes in Lightroom, Photoshop, where you can just click a button and put that in there. Sometimes for things like portraits, you want to focus on the person's face, or you want to focus on the center of the image. That's fine. But for most of this type of stuff, I don't know, most people tend not to want it. But again, that's why for wide angle lenses, just for normal photography, when you buy your filters now, even if it's just a protection filter, clear glass, UV filter, a lot of the manufacturers, the better ones, make thin filters. They cost more, should be less, right? It's less glass, but they make thin filters. And for wide angle, you want to get those so you're not clipping the edges of the filter, the metal ring. Okay, technique. Fairly simple. This is what I like about this one shot. For focusing, turn off your autofocus. It's not going to work at night. Turn off image stabilization. Whenever you put a camera on a tripod, turn it off. It'll get confused if anything else is moving, and it'll start jumping around and can wreck the shot. Find the brightest star or planet. Venus is great right now, right? With manual focus, what I like to do is bring the image up on the screen on the back of the camera, and then go to like a 2 or a 4x magnification. Anything more, and when you touch the barrel of the lens to focus it, and it's just jumping all over the place, and it's just annoying. Unless you've got hands like a surgeon, then maybe you can get away with it. I don't. To get even better, I like to bring a magnifying glass, just a cheap little magnifying glass, 3x, 4x. So that way you're magnifying the back of the screen, hold it up to it, rather than actually magnifying the image where it's just jumping all over the place as you're trying to focus and the star or planet just keeps going off screen. Very frustrating. I find that this works. So minimal magnification back of the screen, bring a magnifying glass. There's also a hood that you can clip over. It's kind of like rubber band, and you put it over the screen on the back, and it's got a built-in magnifier. It has diopter correction too. I think it costs about $50. You can use that. Look for pinpoint sharpness. Go back and forth a couple times. Once you get it locked in, you're good to go. I like to periodically check it at night, just in case something bumps something. Some people recommend focusing on something at infinity, far away in the daytime, and then tape it. I find that I just don't like to do that. Again, maybe I don't have the steadiest hands, but as you're taping it, sometimes you can just move a hair, and that can just cause enough blur that you'll be dissatisfied with your images. More exposure settings. Now, this is what I use. Your camera may be more or less sensitive at night. So test. It won't be far off, but you have to test. Also, according to where you are, down here, we're in a light polluted area. Your exposure is going to be shorter, or else you're going to pick up all that light pollution and just wash out everything. So the exposures I take down here outside of Philly are shorter than if I'm up at Cherry Springs or Blue Mountain. So set your camera on M, manual. Again, I already mentioned turn off the autofocus. ISO, generally, for this type of work, 800, 1600, 3200, maybe 6400. The shot that you saw on slide 1 was around 3200, and I think was around 20 seconds. Exposure time, probably 15 to 30 seconds. We'll talk about a rule on what to use in a minute. F-stop already said as wide as possible. That will get your exposure time down or get your ISO down. So try to decrease shutter time and your ISO as well. Now, if you look on the side, I took 2 shots here of something that I blew up significantly. The top photograph was shot at ISO 100. The bottom shot was at 6400. And you can see that you get noise. Now, there's ways to deal with that with stacking photographs. There's other ways to subtract it. You're getting into software. And in post-processing, there's ways of denoising things. But bottom line, the higher the ISO results in lower image quality, noise. I know that Lou's going to talk about something that is going to vary from that. But just in general, for one-shot photography, not stacking. Okay, you're also going to use a remote shutter release or possibly the built-in timer. You know, the one that lets you run in front of the camera, take your picture with your family. So the Canons have 2 seconds or 10 seconds. Push the button, lets everything stabilize. Because when you push it, you know, you're going to get a lot of shake at first. So you got to let it stabilize. There's also a cell phone app that you can use to remotely control it. It's one more thing that you're looking at that's bright, and it's one more thing that could go wrong. Batteries die. You can also go hardwired. The intervalometer, there's a picture of that down in the bottom. That's the one for Canon. These are specific to a camera, even within the manufacturer, because the cameras have different pinouts. I think Canon's got 2 or 3 different pinouts where you connect it. Both of these, the cell phone app or the intervalometer, will allow you to exceed the camera's 30-second limit. You might want to go with 60-second exposures. In that case, you're definitely going to need either the app or the intervalometer. It will also allow you to do really long-timed exposures, which you can see on the side. This just went really long. That's the only photograph in here that's not mine. But you can allow it just to like run through the night, and you get, or even pick it up the next night and stitch it. and you'll get the circles, right, going around Polaris. You'll definitely need one of those because, again, most of the cameras have a 30-second max limit. Polar alignment. For the shots that you'll see in here, I did not use it. When I got to Cherry Springs, it was late, and I just didn't have time. And it worked out. For wide angle, you can probably get away with it. Now, the rule that I was talking about, the 500 rule. So you divide the number 500 by the focal length of your lens. And the result is the maximum amount of time in seconds without excessive streaks. This is for unguided, no tracking. So say you're using a 50mm lens, 500 divided by 50, 10-second max exposure. Personally, I like to cut that in half. It's a matter of personal taste. So I used the 16 to 35 set at 16, so 31-second max exposure. So I was good in the 20-second range. Now, manual Barndoor tracker. If you Google that, put the word astrophotography in there, you're going to get all kinds of other crazy stuff. If you Google that, you'll come to this site for the plans to build it. It's very precise. You'll need a drill with a metal drill bit and some parts, some screws. You can build it for 20, 25 bucks. You'll point the hinge at Polaris, look through it, or you could use a laser. I found that that works out better, provided, you know, if there's nobody around. Lou is going to talk in a lot more detail about techniques for polar alignment with autogliders. Again, this is quick and fast. So here it is. This is the one that I actually built. The movement, I took the lid from a large butter dish. And then I went online and found a protractor, a 360-degree protractor. I scaled it to the exact size, printed it, and taped it to the lid. I cut the sides off. You want this thing to be soft and flexible in case you're a little heavy-handed on it. You don't want to start moving the camera and the whole thing. So again, point the hinge up at Polaris. I think this is coming up in the next slide. The bottom one I also built too. This one's motorized, runs on a 9-volt battery. You'll notice on that one that I did put on the top a rubber washer on the top to dampen the vibrations from the motor. Both of these worked out quite well. You'll see that coming up. And here it is with the camera sitting on it. And with the laser pointer on the hinge, just line it up with Polaris, good to go. Then you move the camera wherever you want to photograph. And then what you'll do is you'll manually just rotate that counterclockwise to raise the hinge. Now, be careful. You get to a certain point, probably shown in the lower left, the weight of the camera is going to get past the hinge and it's going to be camera overboard. And it's going to crash down into the metal leg of your tripod, and it's not going to be a good day. Make sure that you carry spare screws. You're going to drop them at a dark site, and the wrench is to tighten everything up. Lou's going to talk about things that need to be tight, and even though they're as tight as you can possibly make them, they're going to get untightened. So take the tools with you. You don't want to be out there, something gets loose, and you're like, ah, wish I brought a wrench. Left side is 30-second exposures without tracking. The right-hand side is the same photograph using the Barndoor hinge that I just showed you for 30 seconds. So this is, the top is the dipper part of the Big Dipper. And the bottom was some other star, I'm not sure which one. But you can definitely see the difference in the bottom, how a 30-second exposure. I used a 100mm lens on this, just to magnify the streaks. You can see how on the left-hand side, you're getting the star trails. For wide field with a wide angle, you're probably not going to notice it if you as long as you don't blow the photograph up really large. But again, this was 100 millimeter, which I found was the max that I could do with the manual Barndoor tracker. You'll see that using it on the right, significant reduction in the movement. Now let's talk about composition, because if we're looking at these wide field shots, you're probably going to want them to be interesting, and there's a couple things you need. The rule of thirds, that's what I use all the time. Whatever way you have your camera oriented, divide the screen up into thirds. Good old tic-tac-toe board. Interesting foreground is very helpful for this. And leading edges. This applies to any type of photography you do. So if you look at the lower left, here we have a photograph taken off the bridge up in New Hope. And on the right, we have Cherry Springs. So let's look at how the rule of thirds applies to those. So you try and line objects up along the rule of thirds, and the most interesting points would be at the intersection. Bottom photograph, it's the boat and the clouds. And leading lines coming in, typically you'd want them to come in from the left, because we read and move our eyes from left to right. But in this case, didn't have anything interesting over there. So the leading lines are coming in. A little bit hard to see, but there is a rope that goes from the bottom corner out to the boat. The photograph at Cherry Springs. Now, again, if I tilted down a little more, but I really wanted the Milky Way. If the trees were a little taller, they would have lined up along that bottom line. But leading lines, top right, lower left. And this is simple. You get in the habit of it after a while. Now, light painting or two exposures. So again, I said this is going to be single, but these are a couple other techniques you can do without getting too far off of that. So here's the same photograph, same exposure, taken Cherry Springs. One on the left is with light painting. Same shot on the right without it. What is light painting? Well, bring along a flashlight, make sure nobody else is around. And for these, I used a mag light, 300 lumen mini light, fits in your pocket. I was probably about 100 feet from the trees, and I stayed on the side where the cars are parked. Still somebody yelled. You want to take the light and you want to move it back and forth during that 30-second exposure. Make sure the light isn't hitting the back or the front of your camera, because light will leak through the viewfinder on the back of the camera. So kind of move away from your camera. Move back and forth along the tree line rapidly, maybe even jiggling it up and down a little bit as you go. If you hold it still on one spot, you're going to get a hot spot. It's going to look like artificial light. You can even, if you have enough time, step to the side, 10, 20 feet. The more angles you get, the more natural it will look, but do not stand still with that light. Keep it moving. Again, 20-second exposure on the camera. I think the light was on for about 10 seconds, moving it back and forth. And it just adds a good foreground for composition, makes it interesting. Also at Cherry Springs, and I was looking on aerial satellite maps for a lake that was nearby, and it turns out that there's a reservoir about 5 miles, I believe it's north of there. So I drove up there during the daytime so I'd find it and make sure I knew where the edge of the lake was. Because at night, guess what? You can't see it. Yeah, almost. So this was shot on the same night as the last shot that you just saw. And I got what I wanted. There were some hills around there. Obviously, the water's at the low point. Got some reflections. Even though it's in the shadow without any light painting, that tree, I used that to frame the shot. It just adds to it. These are actually two separate shots. The Milky Way was actually taken down at Cherry Springs, and the lake was taken there. I had to merge it because otherwise I would have been in the middle of the lake trying to photograph this to get it to line up right. So it just didn't feel like getting wet. Okay, again, two shots. The lower half is downtown Bryn Mawr. And for those of you that used to go with us to the restaurant up here that we no longer go to, Galileo, you can probably see it all the way over on the right. You can see the roof of it there, kind of white. But anyway, the Sunoco station there you might recognize. You'll also notice that there's snow on the ground. So this isn't the winter. The Milky Way is not up. So yeah, something's wrong. The top half is the shot from Cherry Springs. Bottom half is Bryn Mawr. So Cherry Springs meets Bryn Mawr. Merged together in Photoshop. For those of you that are purists, yeah, you're cringing. I look at this as artwork. I want everybody to have fun, create some nice images, hanging on the wall. Family's going to go, wow, how'd you do that? It's different than just pure technical photography. The lighthouse in Atlantic City. Again, something's wrong. It's a highly light polluted area. You would never get this. So two separate shots, both of them obviously at night, and merged together. Artwork. Now, how to do this in Photoshop, again, we can get into that in one of the workshops if there's enough interest. That's beyond the scope of this right now. It's not that difficult to do, but it would be too lengthy for right now. All right, one last point. Speaking of Corona, similar to the SETI project where people are downloading some software and letting the SETI project use their computer to crunch massive amounts of data, one of the research hospitals down south is doing something very similar in order to come up with a solution for Corona. They're mapping the DNA, they're looking at drugs and how they can interact. So they need your computing time. And it's called folding, which is the way the proteins fold up, foldingathome.org. So if you've got time, you want to give some of your computer time when you're not using it to them, go there, download the software, get online, help cure this thing. Thank you very much. I hope you enjoyed that. It was a high level view. Again, stuff that you already own, and just go out, simple, don't even need to do polar alignment. If you want to, you don't have to buy anything expensive. You can make the hinge for about $20, $25. So I'll take some Q&A right now, not too many because I don't want to cut into lose time. So
I have a question, this is Lewis. How much effort did it take you before you felt like you were doing good and getting good pictures? Was it like it happened immediately? Did it take a year, 2 years? I mean, give me some scale.
So I think one of the first times when I went up to Blue Mountain, I attached my camera to the back of Lou's telescope thinking I was going to push the button. And yeah, we've had people even come to the club beforehand, and then they've taken off real quick when the meeting starts, and they've come up to Lou, they've come up to me. How do I do this? Tell me what setting on my camera. Tell me how to set it. I want to take nighttime astrophotography and get the Milky Way. Well, you can't. It's not, you know, what do you mean I can't? And I was kind of under the same impression too, which is why I wanted to put this together now that I kind of got it down. Yeah, I went up to Blue Mountain. Lou was there. He was kind enough to let me attach the camera to his telescope. And what did I get? Dust. Dust on the sensor. That's one of the problems with hooking a camera up to a telescope. Nothing else.
Those were stars, Irv.
Those were stars. Okay. Yeah, it could be. No, I think, yeah, there was some, but I did not get what I wanted. Let's put it that way. I watched a lot of YouTube videos and read a lot of books. So I would say 6 months to a year before I really said, okay, all right, this is what I need to do it, which is what I just showed you. And now it's just coming. So yeah, probably inside of a year for this. I think that the deep field stuff, being it's a lot more technical, a lot more precise, is probably going to take even longer. because a lot more software that you have to learn, a steep learning curve on that. For this, I would say 6 months to a year. If you just go out and follow those rules that I gave you, you'll probably be able to nail it a lot quicker than what I went through with the trial and error. Other questions?
Yeah, Irv, I don't, maybe it's not a question, just like kind of a workshop suggestion. I always found it difficult, like I take a long exposure of the sky to get the Milky Way, and then I try and take an even longer exposure to expose the foreground using whatever kind of natural light there is. Maybe there's a moon behind me or something, but I can never get it really right in Photoshop. So I think maybe if you could do a workshop in the future, kind of like explaining what that process is to make those like composite images, I think that'd be really cool.
Yeah, that's on the drawing board. Thank you. Good suggestion, and it's good that we have some interest. Real quick, one of the things that some people do is they wait till right around dusk, which I think is when the lighthouse was shot. It wasn't like fully dark yet. It was like that blue sky. That's probably when you want to shoot that. Maybe even bracket your exposure so you get something that will look like it's at night. And then that's going to be your foreground picture. And then you'll merge that later. Some people do it in the daytime with underexposing. That looks, to me, that looks hokey. There's just a difference in the temperature. But yeah, it's not that hard to do in Lightroom and Photoshop, but it's going to take at least an hour or two to explain. So good question. Others? Okay, let me turn it over to Lou, because I know he's got a lot of stuff to go over, and thank you.
Thanks, Irv. Go ahead, Lou, it's you.
You guys hear me? Hello?
I can hear you.
hear you loud and clear.
Yeah, we can
All
hear
You're
you.
good, Lou.
Okay,
Gotcha.
here we go. Let me turn off my camera here.
Lou, we do have one question, which you can answer, perhaps Irv can answer too. And that is, are there any suggested areas to try shooting closer than Blue Mountain?
Sure. Green Lane Park is the darkest area in Montgomery County, French Creek. And if you use light pollution filters, you can even, if you can see the images here, the one here on the bottom left, I took that from Norristown, about, I don't know, a mile, 2 miles away from King of Prussia. But that's a relatively bright object, the Orion Nebula.
So for single shot, you're going to have to get as dark as you can. Blue Mountain will work. I don't know so much about around here if you want to get the Milky Way. For other objects and stacking,
No, well, you can get
you could
some
be
actually.
closer.
I've got some from my backyard. I don't have any ready to show you now, but you know who else? I think Andrew took some, but I don't know if the Milky Way was up or not when he did.
Yeah, I just took some, with these new smartphones, they can take pictures. I would just suggest taking pictures wherever you can, to be
Yeah.
honest. You might not be able to see the Milky Way. It might not be what you wanted, but it's a way to learn the camera. And that's my suggestion.
Okay. All the pictures you see here were taken with a DSLR camera, the same one. It's actually a camera that I wound up getting for free, which is the best kind. It's a Canon EOS Rebel 1000D. They don't even make it anymore. It's only 10.1 megapixel, but I'm gonna say only, that's plenty. And the reason being is it's enough, the pixels are big enough so that the camera is not noisy, and it's enough to have a high resolution image. Okay, I'm not gonna go over the details of how I made all these. That's for a different presentation. But what I am going to go through is the process on how to do this if you want to get started. Okay, so let's see. My pointer is not working. Here we go. Yeah, it's not working. Keyboard's not working. I'm stuck. Can you guys still hear me?
Still hear you.
Yeah.
Yes.
Yep.
We can
For some
hear you.
reason,
Mouse
I
is
am.
moving intermittently.
Say that again?
Your mouse is moving.
It's in the lower left screen now.
We can
Lou,
confirm that.
try exiting full screen PowerPoint and bringing it back up. Sometimes that helps. Yeah.
Yeah, we could see the mouse.
Yeah, your screen wasn't frozen. It just seemed like PowerPoint was.
Okay, how's that?
We can see you. I don't think you're sharing the screen.
I see your desktop, not the presentation.
How's that?
Got it. Got
Okay.
it.
All right, let's see if it works now. Yay. Okay, everybody see that?
Yes, sir.
All
You're
right.
good, Lou.
So here's the outline of what we're going to cover. The equipment you need for deep sky astrophotography. The most important thing really is going to be a mount. The telescope, believe it or not, is not that critical. But to have a sturdy mount, one that tracks evenly, accurately, and a solid foundation to put it on, either a tripod, but a pier would be better if you have someplace permanent. And you want the mount to be remotely controllable. Most of them are. The next thing you're going to decide whether you're going to use a camera or a telescope. You need dew abatement equipment, because if you're going to be out there all night, dew is going to drop all over your equipment. Then you need to decide whether you want to use a manually adjustable DSLR or a dedicated camera. Since I got my manually adjustable DSLR for free, I use that. One thing you could do to the DSLR is the sensor itself sees the full spectrum where your eye doesn't. So what Canon does and Nikon does and all the manufacturers, they put a infrared cut filter to cut out the infrared light from hitting the sensor because your eye doesn't see it, so it matches more closely what you see. Well, you can have somebody remove that filter because there's a lot of things in space that are in the infrared range that you need to see, or the camera needs to see. And you can also get clip-in light pollution filters. Some of them are made actually pretty thin, but you know, they are a pain if you're doing wide angle. So you could buy a dedicated astrophotography camera if you wanted to, but if this is the first time you're doing this, I would avoid it. It get very expensive, but there are some advantages. All right, then you need to figure out how you're going to align your equipment. Finder scope, laser pointer. I use something called a pole master when I'm mobile, and you can also use software to help you as well. Some way to focus, because in the dark, it's not easy. A batten-off mask comes in pretty handy. We'll go over that later, or an autofocus, and I'll go over that as well. Computer is very important. It makes your life so much easier.
Here's number counter. 1, 2,
And
3,
a USB comes in handy as well.
7, 8, 9, 10.
A guide camera or an Autoguider is also necessary.
20, 21, 20.
You can use a separate guide scope. That is pretty handy in some situations, but it causes some problems. An off-axis guider is what I prefer to use, but there are issues with that as well. We'll go over both. You have to figure out some way to power your gear when you're out in the field. Then you need processing software to manage your data after you collect it. And then you need a dark sky. But if you have new gear or you're just starting out, there's no reason to wait for a dark sky to fumble around your equipment trying to figure out how to use it. If the moon's out and the sky's clear, get out there, use your equipment. Don't waste the clear sky. know it so that when the sky is clear and there's no moon, you don't waste any time. The last thing you need, now if I had to make one slide over again 18 times, this would be the one. Patience. I can't tell you how many times I wanted to drop kick my gear across the street, into the pool, into the lake. You have to have patience. If something's going to go wrong, it will. All right, so when you're choosing a mount, a German equatorial mount is the best mount of choice, although you could get away with using a different type of mount, but on a very limited basis. So when you're looking for a mount, you want to buy the best German or best equatorial mount you can find. Make sure the tripod is sturdy, or you can mount it on a pier. The reason why this type of mount is preferred is because it only rotates around one axis. So basically, you point the mount's rotational axis exactly north, and if you have that right, then the mount is only it's gonna track across the sky as it spins in the same direction as the Earth does. To get that going requires some work. You have to obviously align it to the North Pole. And once you get that aligned to the North Pole, then you gotta let the telescope know where it is on the planet. It can get kind of tricky, but we'll go over that. You also have to make sure that the mount can handle the weight you're gonna put on it. Usually mounts, if it says the capacity is 30 pounds, if you're gonna do astrophotography on it, the capacity, I would limit it to 20 pounds at the most. You know, you can expect to spend at least $2,000 on a mount, and even that is cheap. Anyway, don't buy a mount less than that if you're planning on doing astrophotography, unless you're only planning on putting your camera on it. All right. So here's an example of a German equatorial mount. These are both the same type of mount. This one is just in one position, and this one you can see. Here, I'll show you. This is the axis where everything rotates off of. So this right here points toward the North Pole. That axis there, that axis there. All right. The other type of mount is an alt-az mount. These mounts you might have, they're great for visual observing, but you notice there are only two axes, and they move at different rates as they track the star across the sky on each axis. So they're not ideal for astrophotography. They're great for visual. This type of mount you could put a wedge on if you have one that will tilt it so you get the third axis, but because it's not designed to be that accurate, you're going to have a lot of problems with gear slop and accurate tracking. But you may be able to get away with taking a picture of some of the brighter objects like the planets or the moon. So don't buy this type of mount if you plan on imaging deep sky objects. Okay, so the next two slides we're going to talk about are the different types of telescopes. I'm only going to cover 3 different types and 2 varieties of one, but all this is showing is the different path that light takes in each of the telescopes. So this is a typical refracting telescope where the light comes in from here, and then the image is flipped and your eyes here, and you look at it this way. So this uses the lenses to bend the light into focus. The cheaper ones are achromatic, and they focus the different wavelengths of light at different places. So you get a funny fringe or color fringe, and you can never get perfect focus. It's not very good for astrophotography. But they do make ones that have lenses in the front here that correct for all that. They're very handy because they're very portable, and they're great for astrophotography, but they're very, very expensive. So If you're just starting out, I would avoid that. The other advantage for this type of mount is you don't have to collimate it. Now, the reflecting mount, for example, this one down here, the light comes in on this side, bounces off this mirror to this mirror, and then up to your eye. Or you can stick a camera here. Let me get rid of this. These are a lot cheaper. They're a lot bigger. They're harder to move. They don't cause the chromatic aberration problem that these do, because it uses a mirror rather than a lens. The light's not bent through the lens, it bounces off the mirror. The other problem is this mirror right here always goes out of alignment, and you have to adjust it almost every time you use it. The other type of telescope is a Catadioptric Telescope. So this is like a combination of the two. It uses both mirrors and lenses to bring the light into focus. They're very compact, they're portable. You usually don't have to worry about chromatic aberrations. The light comes in through here, bounces to this mirror, bounces again here, and then back out to your eye over here. Same thing with this one. The difference between this type and this type is the corrector plate. Now there's a piece of glass here and a piece of glass here. You can notice this one is a spherical concave shape here, or I guess whichever way you're looking at it, convex. Anyway, the function of these plates is to correct any aberration in the image. Okay, so here's how I power my equipment when I'm at a remote site that doesn't have any electricity. I use a deep cycle marine battery. I got this one at Costco. And this thing is very handy. It's a trickle charger. It's called a battery tender. I love this thing because it slowly charges the battery. You leave it plugged in. Actually, this picture, it's not plugged in. It's plugged in down here. I just leave it plugged in constantly, and it never overcharges the battery. It knows when the battery charge is running low, gives it just enough to stay topped off, and stops. What's great about this is the connection here comes apart, and you can easily attach the cigarette lighter adapter or any other connection that they have available. You can just plug in there. So all you have to do is unplug it from here, pull it away from the wall. I always leave these plugs in to the post. It's very convenient. Although I have to say I haven't had a chance to use this exact setup yet, since I have a permanent pier and I don't feel like moving my equipment. Okay, so Dewey Bateman equipment. For my particular telescope, I have a Schmidt-Cassegrain. I use this dew shield. This dew shield is also powered. There's an element right here, right around here, that heats up the area just slightly above the ambient temperature so that dew or frost doesn't drop on the corrector plate. Very prone to do that. So this dew shield is controlled by this dew controller, which I have mounted on this dovetail up here. Now you can see this is the inside of my observatory. The shed rolls off. There's a computer, and I have red tape everywhere. There's blue lights on here. They mess everything up. And there's a light off that power supply that I covered up. All right. So we're going to talk about mostly about CMOS cameras, but I do want to mention the Ccd cameras so you know the difference. For the Ccd camera, it works a lot like it collects a light a lot like a slide, or a film does. It passes through all at once, so it collects all the information at once, and each pixel doesn't amplify the signal. They get amplified after light's collected. They're very efficient. They're great for astrophotography, but they're very expensive. The other type of sensor is a CMOS sensor. Each one of the pixels has its own little amplifier. They're a pain if you have really fast motion, especially in low light or a flickering light, because of the way the sensor works. But even though we're shooting in low light doing astrophotography, there's not a lot of action. These are very cheap to make. These are very common. They're found in your phone and any DSLR camera you're going to buy. Okay, so the newer DSLR cameras actually handle noise pretty well. I mean, not as good as CCDs, but good enough to do astrophotography. And that's the model that I use. I got mine for free, but you can buy it on eBay for $50. Or you can buy a dedicated camera. The advantage of that is they have added cooling. They're expensive, and you can only use them for astrophotography. And when I say $500 to $1,000 for an entry level camera, that's for the cheapest, junkiest one you can get. You're not going to like it if you spend that much. There's a larger variety of sensor sizes and pixel sizes with these cameras. And you can also find them in monochrome. Now, there's an advantage of shooting in monochrome, because most of the one-shot color cameras, well, all of the one-shot color cameras have what's called a bare matrix. So the pixels are grouped together 4 at a time. There's 2 green, 1 red, and 1 blue, and that's how you get the color image. So that actually effectively decreases the resolution of your camera. Where you have the monochrome camera, you can have basically, let's say it's a 10 megapixel camera, it would be the same as a 40 megapixel in one that has a bare matrix. The disadvantage to that is it takes you 4 times as long to collect data, because you have to shoot 1 frame for luminance, 1 red, 1 blue, 1 green. Anyway, it's very tedious and cumbersome, but you get great quality images. Okay, so here's an example of the different sensor sizes. Now, this is not obviously real life size. This is just a comparison of the ratios. The sensor size will determine how much light you're actually you're gathering, because the hole that the light's coming in from the camera, or the telescope, is going to be bigger than the actual sensor itself. So you can see if the light coming in has this much space, obviously the 35 millimeter full frame is going to capture more of it, whereas your crop sensor is going to capture what's in the center. So the field of view is better. I'm not going to go into too much detail. Irv talked about this. One thing I will mention is the larger the sensor, with the larger pixel, the better quality you're going to be, because it's going to handle noise better. Since each pixel is amplifying a signal, it's also amplifying noise. So if you have fewer pixels, you're going to get a cleaner picture. So high quality 10 megapixel full frame camera will produce much better images than a 24 megapixel low end camera. All right, so here's my camera and here's the settings. I put manual. You have to make sure you shoot in RAW. Your white balance is custom. I like to shoot with ISO 800. I always set the resolution to the highest. You got to make sure your red eye is off. There's a stupid little flash here that I never use, but occasionally pops up without me knowing it. Gets me right in the face, and that's ruins my eyes for about an hour. Also, if you're going to use just your camera without a computer to frame and focus, turn off the image viewer when you're done, because that will help or add to heat up the sensor. So remember that, and then turn your autofocus off. Here's how you connect the camera to the telescope. You need one of these bayonet adapters. This will connect to your camera. It's specific to the camera you have. And then this connects to the back of your telescope, and then that screws into here. So that makes it easy. Okay, so Irv showed a picture in his presentation about the two different Canon cameras. One was modified for astrophotography, one wasn't. I talked about earlier that you can remove the filter in front of the camera to see the full frame, the full spectrum. So when I did that for mine, this is the image I got from my backyard. The reason why it's all pink is because it was balanced. The white balance was adjusted for the human eye with the filter in place. So if you remove the filter, you're going to have to make sure you reset the white balance. So when the white balance is reset, you can see this is a 30-second exposure taken in Norristown from my backyard. You can faintly see the Milky Way here. I mean, here you can make out Cygnus right there. You can see there's Alberio, there's Deneb. You can see Le Gentil 3. And this is barely, but it's only a 30-second exposure. Mind you, I took this with the moon out. It was high in the sky, and there's street lights everywhere. So the infrared does make it a little more sensitive. And also, look, you can see green at night. And this is midnight. The sky's blue. At midnight, when you look up, your eye can't see that. All right. So it was hard to adjust the white balance. But one of the ways I found out how to get it right, I knew my neighbor's shed here was white. So I took a picture this way, and when that was white, I knew I had it right. Here's a view of my backyard now from my observatory. All right, so I want to spend a little bit of time on aligning. This is one of the most tedious processes, and you have to get this right to get good data. Your mount has to be level. It's got to be balanced properly. You want to have it balanced slightly, ever so slightly heavy to the east. So the gears are always being pushed on because the telescope is moving up from that direction. Also the deck axis, even though the deck axis shouldn't really move if your polar alignment is on, shit happens. I like to keep the deck axis slightly heavy toward the back where the camera is. Try to use gravity to your advantage. So here's some techniques that you would use to start your polar alignment to get a rough alignment. The COCHAB clock will give you an idea where north is with respect to Polaris. So at 9 o'clock, on September 15th, you look across, there's COCHAB, look to Polaris, the North Pole is slightly to the left. So this is a quick and dirty way to get everything aligned. A lot of telescopes have a hole through the RE axis where you can put a polar scope. This serves the same function. You would place Polaris in here, and it'll point to the celestial pole as long as you have these two constellations oriented correctly. This is useful, but a lot of times this reticle is not illuminated, so you might need a red light to see. I like to use a Polemaster camera, which is placed on the RA axis, and that allows you to plate solve, and you can get accuracy within about 30 arc seconds within about, 5 minutes. You can also use a Talrad to help you, or a laser pointer. The other thing that is important is to have your location accurate. And not only location, but the time's got to be right on. So especially if you're zoomed in with a long focal length, because if you're off by a little bit, it's going to be evident. I like to use a GPS. They make them specifically for telescope mounts. The one I bought was $120. it's worth every penny. I still use it even with my stationary mount in my observatory. All right, another way you have to line after you're done polar aligning. You have to line where you are in the sky. So you got to tell the telescope where it is. So there's a 2-star alignment, 1-star alignment, and then you can add calibration stars. I get mine roughly aligned, and this piece of software is awesome. So if I get pretty close, I'll tell the telescope, hey, look, I want to take a picture of this object here, right in the center. You know, if it slews to the place right here, it'll take a picture. It won't see this, but it will see these stars, and it will know if it's close enough. Okay, it'll change the sensors inside the mount so that now it knows it's in this position. And then the next time you align, boom, comes right onto the center. So this makes it very easy. So every time you turn on your telescope, you can be sure just by pushing a single button, you're going to come to this object every time. The other thing that's really handy about having everything aligned like this and using this piece of software, you could tell this thing to, let's say, take a picture like this. Take another pane here, another one over here, you know, maybe another one here, like that.
What is this software called?
It's called Sequence Generator Pro.
How much does it cost?
Okay, so my wife here is helping me out. This software, Sequence Generator Pro, it cost me $75 at NEAF. I bought it 2 years ago, 3 years ago. I think it's $100, but if you wait till NEAF, you probably could buy it for 75 bucks. It is invaluable, but I'm not going to go into too much detail about this now. I'll do another presentation for people that are interested in using it. But what's great about this is you can set a sequence up to do, you know, this. So every time you come out, it'll slew your camera to these different squares. Exactly. So you can, you know, maybe one night you only have enough time to collect these 3 squares. The next night you come out and you get these 3. And then you go back and forth till you get enough data to stack. So you get a clean picture. And we'll talk about that in a minute. Okay, so focusing, it's a real pain. Different techniques for different types of astrophotography. For a wide field camera, you turn off the autofocus. You want to increase the ISO when you're framing your subject and when you're focusing. That'll help you see things better, obviously. You also want to increase the digital magnification as much as the camera allows. Focusing to the infinity mark doesn't always work. You know, you could try focusing on a distant object during the day. I like to use tape, but then what I do when everything is focused and it's confirmed, I just draw a line across the spot. So if it does move, then you can just match up your line. Because, you know, like Irv, my hand is not very steady. So it's going to move. If you draw the line, then you know you got it. You can also use software to help you. Here's a couple of examples of software. A lot of these are free or inexpensive. You need a computer, obviously, but what's great is you can plug your computer into the computer monitor, and now instead of looking at that tiny little LCD screen, wow, you have this enormous screen that you're looking at, and you can see if something is in focus. Because I'm going to tell you, if you try to focus once, just using that tiny little LCD screen, it's going to look perfect until the next day when you put it on your computer. You're going to, oh man, you were off just a little bit. So this works great. If you attach your camera directly to a telescope, you're not going to get focus without any type of help. I like to use any of these programs or Sequence Generator Pro. The advantage of using, you know, one of these programs, Backyard EOS or Backyard Nikon, what it does is it tells you the average radius of the star and it gives it a number. And as you turn the focus, the number goes up or down. And you know, you want it the lowest number possible. It's also very tricky because when you're adjusting focus, you know, everything's going to shake. especially if you're on the back of a telescope. The other way is use a Bahtinov mask. This I love. So we're going to go over that next. This was a genius invention. So this Russian dude invented this thing, I don't know, 2004, 2005, I can't remember. But anyway, these diffraction spikes make a particular pattern when the telescope is close to focus. So you get as close as you can with your eye, and you see you make an X. And as you move focus, this vertical line will move this way or that way, left or right. When you have it exactly in the center, that's how you know you have perfect focus. This takes all the question out of it. So the way to use this thing is you find a bright star, you take a 1 second exposure, see where you are, adjust it a little bit, take another second exposure, adjust it a little bit till you get it close. Now keep in mind, with some telescopes, the temperature variation of just 1 degree will cause a shift in focus. So yes, this is handy, very helpful, but it's tedious and it takes a lot of time, especially if you got to stop and focus all night. What I like to use is Sequence Generator Pro. Haha, my favorite program. This has an auto-focusing routine, but in order for you to use this routine, you have to have a hardware autofocuser. So basically, what the device that I have has a motor that moves the camera back and forth until it gets focused. But the important part of this machine, it knows exactly where it is in its movement. It's called a stepper motor. It assigns each one of these steps a number. So what it does is you use the Bahtinov mask, for example, to get close to focus. And then you move out the focus, tell this thing to move out a predetermined amount of steps. It will move out, take a picture of the star, and then it'll measure the radius of the stars and plot it on this graph. And it'll move in focus the same predetermined amount, and it'll measure the radius again, and it'll plot that again on this graph, and it'll keep getting smaller and smaller until you get closer to focus. As you go past focus, the number will get bigger and bigger. Then it finds the bottom of the curve, and it moves the telescope or the camera to that number. That's the spot, and you have perfect focus. This usually takes about 2 or 3 minutes. Since it's working on the images you're taking and it's automatic, most of the time I don't have to move the camera. Actually, I don't think I've ever had to move the telescope to focus. Whatever object I'm imaging, it just stops, takes a picture of the star. So this saves a lot of time. I'm able to get a lot more data accurately just by using this contraption. All right, tracking and auto guiding. You're not going to get any good data unless you track and guide accurately. Okay, so mechanical imperfections in the mount exist. Doesn't matter if you buy a $2,000 mount or a $10,000 mount. Okay, a $10,000 mount may have fewer errors, but they're still going to be there. You have issues with backlash, so that's when there's play in the gears as the telescope's being moved. You have periodic error. That's from the error in the worm gear. Most mounts, you can train that out. If you're just starting out, I would start with a shorter focal length, either using a camera or a short focal length telescope. It's a lot easier. You don't have to be as precise. A long focal length will cause you headaches, nightmares, and you might want to throw your stuff off a cliff. Okay, so for auto guiding, one thing to keep in mind when you're guiding, the seeing makes a huge difference. So what the Autoguider does is you assign it a star. It looks at that star and sees where calculates the center of the star, and it sees how far off it moves from one pixel to the next. When it moves too far, it sends a signal back to the telescope and says, hey, move back this way. So that's one way to correct for periodic error. It sees when the error is coming and it signals the mount to either slow down or speed up. You can do that using a dedicated guide scope. So, you can have a smaller focal length on your guide scope. Most people have a smaller one they use. Some people like to attach a guide camera to their finder scope. One of the issues though is if it's too small of a focal length, then you're not going to guide accurately. You can also have an issue with flexure when you're using a separate guide scope. What flexure is the plane of the image sensors are not exactly in the same orientation, or they move throughout the night. You can tighten things down as much as you can, use super glue. It's going to happen. If something's going to move, even if it can't move, it's going to move. One way around this is to use an off-axis guider. They're more accurate because you're guiding at the same focal length that you're imaging. The problem is there is a much smaller field of view, so you may not see a guide star. You need a very sensitive camera. Sometimes you might have to rotate the off-axis guider, and that can be a bad thing for a number of reasons, and we'll go over that later. Also, if you have a full frame camera, that little pickoff prism that sticks down in front of the sensor will stick down in front of the sensor and block part of your image. Okay, so here's some guiding software that I use. This is called PHD2. It stands for Push Here Dummy. I love this because it's free and it does a fairly good job. Right now I have a picture of it following the star. It's not guiding, it's just following the star, and it's tracking how the mount is, it's plotting how the mount is tracking the star. And you can see here, this almost like a sine wave, it's actually showing the periodic error. And you can see it on this bullseye right here, that it's all along the RA axis. This red line here shows the deck axis, and it's indicating that we're pretty close to a line to the north. So that's accurate. Any inaccuracy here is generally due to the periodic error. These little bumps here, they have to do with seeing. If there's too much turbulence in the atmosphere, the star is going to jump around. So here's what it looks like when it's tracking well. You can see there's still periodic error, but it's not as bad here. This mount is terrible. But anyway, this right here, the line up here tells you the star, the signal the star it's looking at. So if all of a sudden you're watching and this line goes down to here, then you know maybe a cloud went over it or something. All right, so here's an example of an Autoguider, a separate Autoguide camera. You would hook this up either to a dovetail or to your finder scope, and you know they get hooked up through these rings. There's a helical focuser, in the back, and this is an example of this is actually the guide camera that I use, but I don't use this configuration though. I use this. This is an off-axis guider. Here's the pickoff prism. So you see this sits down in front of the camera sensor is, let me see here. The camera sensor is like this right here. Now I have a 1.6 crop sensor, so this doesn't get in the way. But if you have a full frame sensor, it's going to be like this, and that, pickoff prism is going to be in the way. But I love this thing. This camera is certainly sensitive enough to work. All right, one of the most important things about astrophotography, getting good data, getting good images, is having a solid understanding of signal and noise and how the camera sensor works. We are testing the sensor at the edge of the envelope, at the very edge of its ability to sense light. It is absolutely amazing the sensors today, what they can detect with minimal noise. Okay, so noise is bad. It's our enemy. It's generated in a number of different ways. To minimize it, you have to understand exactly how where it comes from. Otherwise, you're not going to get rid of it. It's especially evident when we're doing low light photography, because if there's no light hitting it, the only thing that's going to turn the sensor on is its own electrical current. So that can make everything fuzzy and ruin your picture. But there's more to it than just that. That's one of the factors. The other factors is the nature of light. So light's hitting the sensor in a random fashion. That right there will cause noise because it's not all hitting at the same time. Think about a bullseye. And if you take a shotgun that has 50 BBs in it, if you shoot the shotgun at the bullseye, you're going to get a random pattern. Well, that's what happens when light hits a sensor. It's random. Okay, so this is very important about ISO. A lot of people think a higher ISO will give you a crappier quality picture. Not really. Okay, so when you see pictures comparing ISO that has a grainier picture versus one with a lower ISO that has one that's not so grainy, the reason that is the case is because you're letting in less light with the picture with the higher ISO. So if you set your camera to take a picture of an object with ISO 100 and you have aperture priority, for example, or shutter priority, it's going to let in a certain amount of light, and it's going to let in a lot of light. But if you set your camera to, with ISO of 1600, for example, and try to take the same picture, it's gonna, the sensor is much more sensitive at that. It's the sensor's amplifying the signal to compensate for the less light that it's getting. So that's why you get more noise when you're taking a picture in the daytime with a higher ISO, because there's fewer photons hitting it. So you get that shot noise, the same kind that happens when you're shooting the shotgun shell at the bullseye. There's not enough light hitting it. So we're shooting in the dark. So we need to collect as many photons as possible. And there's a lot of, I'm trying to oversimplify this, but this is, kind of important if you want to get this aspect correct. When you're shooting in the dark, you want to make sure that you take advantage of every little nook and cranny that every little morsel of light that you can capture without having any noise. One of the ways you can get a better signal is by exposing a picture longer or an image longer. But that's not always the case. That's one of the reasons. I wish it was that simple. So yes, a higher ISO value won't increase the noise, everything else being equal. A higher ISO value will definitely increase the brightness of an image. It will decrease the total dynamic range. And in many cases, like astrophotography, a higher ISO will actually decrease the visible noise. All right, so here's a diagram of how camera sensor works. So the light's coming in through here, right? It gets converted, the photons get converted to electrons. And then from there, they get amplified, or they get converted to a digital signal and then move through to your computer. So two sources of noise, there's upstream noise and downstream noise. The upstream noise, it is amplified with the sensor or with the ISO. In other words, if you have your sensor set to too low of an ISO here, as the information moves down here, the noise happening here is going to just overwhelm this signal coming here, and you're not going to see anything. So this is why it's important to amplify the noise here the right amount, or amplify the signal, excuse me, not the noise, the signal the right amount, because you can amplify it here. It's not going to change anything down here. This is always going to be the same. So it doesn't make sense to keep these both the same and then amplify them later. No, you want to amplify this as much as you can because this stays constant. Now, there is a point. Does this mean that a higher ISO means a higher signal to noise ratio? Not really. I mean, it does, but there's a point where once this noise gets too high or this noise is too low, then the signal to noise ratio will scale linearly. Every camera is different. They all have a sweet spot. This link here, if you have a camera and you're curious, I'm not sure if this is clickable or not. If not, copy it down or type a Google search in. It will tell you where the sweet spot of your camera is. You want to find that ISO sweet spot to shoot at because it'll give you the best exposure time with the best quality. You don't want to go higher than that, obviously, because then that will give you more noise. So make sure you familiarize yourself. Very, very important, at least as far as astrophotography is concerned. Now, here's another way you can eliminate noise by using the right ISO, shooting the image properly. How do you know you have enough photons in the first place? Well, use the histogram on the back of your camera to help you set it up. So here's an example of a histogram. This is what your back of your camera would look like. When you're shooting for deep sky objects, you want the histogram to be about 1/3, like you want it to look something like this. This is kind of phallic, I guess, but this is what the histogram should look like. You want it off of this edge here. You want it off the left edge. You want it off that left edge. Because all the noise hangs out right here. So if you can pull the histogram off to the right there, you'll help eliminate the noise. And if you do that by increasing the ISO, as long as you don't go over the sweet spot, you'll have a better picture. All right, so the other source of noise comes from differential flexure. We talked about that earlier. It can come from your guide scope, your guide focuser. I'll give you a better example. I like my little drawings. Let me make a drawing. Okay, so here is the front view of your camera sensor. And then here's a front view of your guide sensor. All right, here's a side view. It looks like this. Here's your side view of your imaging sensor, and then your guide sensor looks like this. Now, what happens is, throughout the night, I don't care how tight you made your connections and use super glue or liquid nails or whatever, they're different metals, different contraction and expansion rates, something's going to move. So what's going to happen at the end of the night or during the night, this might still look like this, but this might look like this. You might be oriented sideways like that. Or this will move and that will stay straight. Something's going to move. And although you'll still track accurately when you're moving, you're going to get this phenomenon. Now, this is a picture of M20. It's an emission and reflection nebula in the summertime. You can see this in the Milky Way. But you see all these little streaks here? This is from differential flexure. See how annoying that is? You can see we're tracking pretty accurately. The stars are almost pinpoint. When I took this picture, I was still learning, so they're not perfect. But anyway, this phenomenon happens when you use a separate, it can happen anytime, but most likely happens when you're using a separate guide scope. All right, how do you get around this? Well, you use a process called dithering. All right, here's an example of dithering. Now, I'm not sure how well you all can see this, but this is a picture of the comet Wirtanen. Came by last year or 2 years ago. I don't remember when, but what you're going to see here is these tiny little dots. These are hot pixels. Okay, all these little thingies here. If you can see that where I'm pointing, they're permanently part of that pixel on the camera sensor. So when we're collecting data, our ultimate goal is to take as many pictures as we can of the same object and stack all those pictures together. That helps improve signal to noise ratio. And I'm going to go over that in a little bit. But one of the problems is if you keep everything in the same place, you're also going to stack these hot pixels together. But if you dither, you can get rid of those because it'll shift the picture between each exposure slightly. So I'm not sure if you're going to be able to see this, but can you see the subtle change? See how, if you can look at this star here, you can see how it moves a little bit. It's just very subtle. But when you dither, it's got to be completely random. So you see that everything's floating. It looks like they're floating around a little bit. Well, what's going to happen is the stacking software is going to select the stars and move the each frame how it needs to be moved to put the stars on top of each other. That means the hot pixels are not going to line up, and if they don't line up, when the stacking software compares the pixels, the job of the stacking software is to eliminate pixels that aren't the same. So the more the more frames you have, the more it has to compare, and anytime something is different, you set the algorithm at what threshold, and it will remove those pixels. All right, I can get into more detail about that in if anybody's interested at another time. We can do a workshop or something. All right, so stacking your data. This is probably the easiest way to increase signal to noise ratio. You can improve the quality of your images, and you can improve it even more by calibrating your images. So there's a lot of software tools that allow you to do this. Some of them are free. You can at least stack them for free, but some of these cost money. At any rate, stacking your data and calibrating it correctly will give you a good final product. So how you calibrate it is you need to take bias frames, dark frames, and flat frames. Probably the easiest type of calibration frame to acquire is a bias frame. If you're going to do any type of astrophotography, there's like really no excuse not to take a bias frame. All you got to do is take the lens cap off. I'm sorry, put the lens cap on the camera and set the camera to the highest shutter speed and just shoot a ton of pictures. What was going to take you 30 seconds. What that does, why you want the lens cap on, is you're actually capturing the innate or signature image or signature noise of the camera. Any noise that camera is going to make, that camera's fingerprint, is going to be captured by the bias frames. Then you also want to take dark frames. Dark frames are taken the same way, except they have to be taken at the same length as your light frames. So if you're shooting 5-minute light frames, you got to take 5-minute dark frames. They're more of a hassle because not only do you have to have it at the same time, you got to have the temperature the same, humidity, everything's got to be the same with your dark frames. That is a challenge. And both of these, what you'll do is you'll take a bunch of bias frames, use the imaging software to stack them together, and you get a master bias. Then you take all your dark frames, stack them together, you get a master dark, and then together you're going to incorporate them into your final image. You'll actually add them to your flats. So how to take a flat frame. You need to have an evenly illuminated surface. I like to use either the pre-dawn sky or, even before I go imaging at night, before the sun sets, I might just take a picture of the sky. I have a semi-opaque piece of acrylic here that I bought from Amazon that I put on to help diffuse the light a little, in case a bird flies by or a plane or something. I don't know. But you want it evenly illuminated. Now you can see there's a gradient here. It's not so evenly illuminated, but this telescope has a really, really small field of view. It's the gradient's not gonna be as obvious. I might wait a few minutes till it's more even. Or, if you don't want to do this, or it's not clear, you wait till you're done imaging. You can make a box and have a couple of these baffles in it. Then just put a light on the top and the baffles will diffuse it. So the important thing to know with taking these flat frames are your exposure's got to be constant. So, the last chart we showed you a histogram. I'm going to draw another one here. So here is your makeshift LCD camera screen. There are the lines there. Okay. So before we had the histogram over here, to capture flat frames, you want the histogram to peak like right around here, right around the center or slightly more. You want it bright enough so it captures everything that it needs to capture. And I'm going to tell you what that is here in just a second. The purpose of these frames is to even everything out, to get rid of the vignetting. If there are any dust motes, any scratches, any kind of grime, any unwanted bits that landed on your your telescope, anywhere in your optical train, you don't have to worry. Flat frames will eliminate them, but you got to make sure that you take them properly. Okay, so the idea is you get a bunch of these, you stack them together, you subtract the master bias, you subtract a dark, and then you get a master flat frame. They have to be taken though, with the telescope focuser, camera, everything positioned exactly as it was when you were taking your image data. So this is why I was mentioning before using an Autoguider, that it's not a good idea if you have to rotate the Autoguider to find a guide star. If you have to do that, it's going to mess up your flat frames. If you have to do that, the best thing to do is buy a more sensitive Autoguide camera. Okay, so the flat image, it gets divided by the normalized version of the final image. That'll smooth out any vignetting. I mean, that is one of the best improvements you can make to your pictures. Does anybody have any questions up to this point? I'm almost done. No questions? All right.
Somebody, Lou, asked if somebody said there's so much information and asked whether the video would be available. And I think the YouTube will remain up.
Yes.
And we'll probably you'll post your slides on the website.
Absolutely.
Thanks.
Yeah, I realize this is a lot of information. Basically, I'm putting this out there as a reference. So, no one's going to remember all this. Gosh, it took me how many years to learn all this. So you can always go back and forth. You might know some parts and not know other parts. And, anyway, so let me finish. We're almost done.
Thanks.
All right. So the idea with the flats divided by their normalized version of the image. So that means the average brightness, let's say the average brightness of any pixel is 1. So the darker areas will have a value less than 1. The brighter has a pixel value of more than 1. So if you divide something by a number that's less than 1, a big number, you get a big number. And conversely, if you divide by a number greater than 1, you get a smaller number. So the result is it smooths out the entire image. And I'm going to show you some examples. Oh, and again, I am going to tell you one more time. Don't move anything. I mean, yeah, you can move your telescope. Don't move the camera. Don't touch the focuser. Don't, none of that. You want to leave everything oriented the same way because the flats have to line up exactly. All right, so here's what 100 bias frames look like stacked together. Now you can see here, this pattern noise here. See the lines? That is specific to my camera. That's my camera's fingerprint, for lack of a better term. There's also some random noise in here, but the reason why we take 100 is we get a better average of where that noise is. So then we stack them together, and then you can smooth that out some more with some processing. So this is the camera signature. So this is the information that we would subtract from the dark frame. We would subtract this from the flat frame in order to get a calibrated image. So here's the dark frames. They look almost the same as the bias, except, all right, this pattern is slightly different, but you notice there's all these little dust motes. Hot pixels in here. That's why you have to take these at the same temperature as your light frames, because you want to account for these pixels, because you want to subtract them out. All right. So here's what a flat would look like. See all this? This is all junk that's on somewhere in my imaging train. I mean, pollen might have fallen throughout the night. I actually think this one is underneath the glass on my sensor, so that's never getting removed. You can see the vignetting here on the side, and so I don't need I generally, because I have my system stationary and I don't move it, I only take flat frames when I need to. Sometimes the same flat I'll use for months. Other times something will happen and I have to take them after a week. But here's a flat frame that I took. It's blue because I took this against the blue, probably the blue sky. Here's another one I took. You can see how this differs slightly. On this one there's some schmeg over here, and on this one it's gone. See? So I think what happened was I might have taken a picture and used this to calibrate. Then I noticed that a spot showed up on the final product. So I went and took another flat frame and compared that. That's what it was, and an easy fix. Okay, so here's a single raw uncalibrated subframe as I took it. You can see all the marks here, the dust grime, pollen, whatever it is, oil. And you can see also the other vignetting in this picture. Not only that, you can see some of the noise pattern here. So one image, that's it, one exposure, that's what you get. There's not much signal, it's a lot of noise and problems. That's what it looks like after you stack together, you calibrate properly. It's like night and day. Now, to be fair, I think there's 157 5-minute exposures to this one. So you can see how much of a difference stacking makes. Now here's another image I took of, this is a mosaic where 2 panels were taken together. I used that technique that Sequence Generator Pro had, where I took a picture of this galaxy first, and then this galaxy, and then later on we added them together, and they overlapped a little bit, like right in this area. But through the processing, I eliminated that. But that's why I like that software. We could talk about that at another time. I hope all you guys are still awake and I didn't bore you all. But I can answer any more questions if they're out there. If not, thanks for watching.
Thanks, Lou. That was nothing if not thorough. Any questions for Lewis?
Thanks, Lou.
Good job, Lou.
Thanks.
Yeah. I have a question.
Thanks, Lou.
So if stacking is so great, why do you take 5-minute exposures and stack those? Why don't you take 1,000 30-second exposures or whatever?
All right,
What makes you decide?
Well, you want to get the histogram off the left edge of the peak of the histogram off the left edge. So if you're taking 30-second exposures, it might not be exposed long enough. You don't want to stack noise. In other words, you need to get signal.
Got you. And your camera isn't fast enough to get enough signal in a short period of time.
Well, it's not with the camera being fast enough. It has to do with.
I meant optically fast.
Well, okay, so I have an F10 optical system. I use a focal reducer to make it F7. I mean, they make faster systems, but to do deep sky astrophotography, it's very rare they're going to be taking a 30-second exposure unless you're doing something like M42 or M13 or some of the brighter objects. You might be able to get away with that, but fainter
Got it.
objects. And also the other thing that matters that I forgot to mention is light pollution. That will also limit to how long you stack or how long you expose. So in light polluted skies, you really can't expose too long.
Yeah, this is Mark Ferrari. I've actually watched a presentation. I have a spreadsheet. You plug in factors like what's the light pollution, what is your camera's capability, what's the pixel size, and you can actually optimize what's the right choice for this based upon maximizing your signal to noise ratio. So it's based on a lot of things that you just touched on, but there is actually a way to calculate for your specific setup the optimum exposure to maximize this signal to noise question.
I believe Sky Tools will also do that.
Yeah.
Sky Tools 3. So
I think
yeah,
that's
there's
what
a
I'm
few
referring
options.
to. Yeah, I watched that guy's presentation and I'm using the math that he presented in that software. Yes.
That is exactly the key.
Yeah.
I mean, the better you do that, the better your image quality is going to be.
So actually, if you have a dark sky, you can do longer exposures and there's a benefit. But
Yes.
if there's a lot of light pollution, you don't benefit from the long exposures.
You're absolutely right.
That's sort of the bottom line conclusion. So.
Well, I mean, if you guys want to hang around later, when the meeting's done, I was going to give you guys a tour of the observatory and the setup that I have. Whoever wants to stick around.
Great, thank you very much, Lou.
Sure.
We're hopefully going to be back at Radnor in a month, but if not, we'll do this again. We got to thank Villanova for letting us use their Zoom account. We may end up with our own Zoom account if need be, but we'll take the necessary steps to go in that direction. Nate Prentice joined us a little bit late. He and I chatted offline. Nate, if there's anything you want to add to the discussion about the main sequence star party in July and the fact that it's touch and go, you can unmute yourself and pipe up.
Sure, no problem, guys. I seem to have no video, but that's okay. I am talking to you guys from an undisclosed location in my hammock with the tarp over it, and basically I'm keeping free of the zombies, so I'm going to have to keep it a little quiet because, you know, they're attracted to noise. It's been like that, hasn't it? So with regards to the main sequence star party, this should come as no surprise, but I have no clue what we're going to do. I can tell you what I have read in terms of what infectious disease epidemiologists are talking about. They're talking about getting a break maybe around August or September before we go and do this again. That's kind of like the lovely scenario they presented. So we don't know yet. But it would be neat to be able to do something in, say, August or September. I kind of doubt that Cherry Springs is going to be free at that point, although it could be. You know, I see Frank is in here somewhere. I don't know what his feelings are about having a bunch of zombies come up to his place, in around August or September, but that might be an option. The other thing is, like tonight, Jeff Oster and I are basically sharing pictures of, he's got his daughter out in the, he and his daughter are out in the front yard camping in the tent, and I'm here in the hammock. So we're kind of swapping photos as the night goes on. So that may be an idea as well, as we could have a virtual, you know, overnight star party where we just share photos as we go through. We're just going to have to be creative with this. It doesn't, just because we're kind of locked down does not mean we can't look at the skies. So that's what I'm saying. So more news as we get closer, to the summer. But for now, that's where we are. And I'm looking for some other ideas as well. Thanks, guys.
Thanks, Nate. And we'll hope for the best and we'll plan for the worst. So this is this would end the formal part of the meeting. I just want to thank Steve, Irv, and Lou for their presentations. That's some exciting stuff. Trying to everybody take a picture on April 23rd. I might just point my brownie star mite in that direction. And Lou will expect a great image from you. You've got time now to work on that between now and April 23rd.
There's no clouds.
Yeah, got to be no clouds. Anybody else for the good of the organization? If not, you can chat. Obviously, Manila's is closed except for takeout.
Missy,
feel free to speak up, but the formal meeting is now over. Thanks very much for joining us. We had close to 70 people between Zoom and YouTube, so this is definitely a good way to go for times like these. Thanks,
Good
everybody.
job, guys. Good job.
Thanks, guys. It worked
Thanks
out
for
well.
coming, everyone.
Bye, everybody.
Thank you. Thanks,
Bye-bye.
guys, and good seeing everyone.
Hey, have a good night.
Good night.
Night.
Good night, guys.
Good night, everyone.
Good night.
So all you guys have seen my setup. And if anyone's interested, I can go over it.
I'm here.
You want to see it, Nate?
Sure.
I need to log
Go ahead,
in.
Lou.
What is it?
I said, go ahead. It's Gary.
Oh, okay. Let me